Hi, everybody. Welcome to our webinar together with IPN Fusion and UfiSpace, our technology partners. Today, we're going to talk about cost-optimized networking for scalable data centers. Sorry, excuse me. You can move on there, Dara. So the agenda today is welcoming all of you, whether it's your morning, afternoon, or evening. We're going to move on to the speakers then, who will present about the data centers. We'll go on to a Q&A. So you'll see the Q&A section available at the bottom. If you have any questions, if you enter them there, we will get to them during or at the end of the seminar. And then we have a QR code there that you'll see on and off throughout the webinar, how you can get in touch with us. Okay, so I'd like to welcome our speakers today. From IPN Fusion, we're delighted to welcome Prasanna Kumara. He's the technical marketing engineer from IPN Fusion based in Bangalore in India. Thanks for joining us this evening in your time. We also have Barry McGinley, our senior systems engineer for EMEA at EPS Global, who is based in Dublin, Ireland. And we also have Kylie, who is the AVP of Technical Sales for UfiSpace, who is joining us today from San Jose, California. So we have all across the globe covered, and thank you guys for joining us at your evening and your morning. Okay, so I just wanted to say a quick few words about EPS Global, who have brought together this webinar for you guys today, why customers choose us. Basically, we have a global reach but a local presence. So we were founded 25 years ago in Dublin, Ireland. We have offices in 28 cities in 16 countries around the world. We give you access to a global supply of your products, supported by a local team. And we also provide local language and currency support in each of the regions where we operate. So you're never too far away from a representative who can help you. So we also provide stock availability and sourcing. That's all the hardware you need, the switches, optics, cables, and anything else you need from our several regional distribution hubs worldwide, which means we can minimize the lead and transit times for our customers. We offer pre-sales tech support in the form of Barry, who you probably all know well from his unboxing open networking fame. And we also have pre-sales tech support in the US and in Asia. So what we do when we can connect you with the right software and hardware vendors for your application. We do the hardware integration from our switch labs, and we also support you through your implementation to ensure success. We also have franchise distribution agreements with our suppliers, so we ensure the quality of the products and that you always have access to the best support that you need. Okay, so this is just a quick map of where our offices are based across the world. And yeah, we're not too far from anyone. We're in all of the continents there. So with that, I would like to hand you over to Barry McGinley, who I said is our Senior Systems Engineer for EMEA. And again, just to remind you, if you have any questions throughout the session, just drop them into the Q&A and I'll ask them on your behalf later. Thank you.
Thanks, Kira. Hey, everybody, wherever you are. That picture that you have there has been around for a while. I think it was during COVID, and my wife could cut the side of my hair, but couldn't cut the top. So I ended up with a giant mop of hair. But anyway, so welcome everybody. So what I'm going to do today is, so obviously we have hardware covered by UfiSpace and software covered by IPN Fusion. I'm actually going to give a general kind of high-level overview of what open networking is, the benefits of open networking, and where we kind of sit in the kind of ecosystem. So open networking, it has lots of names. So you might have heard disaggregation, or bare metal networking, or whitebox networking, but it's all the same thing. Basically, we have, like the server world or the storage world, we have a bare metal switch, a router, and then software goes on top of it. So the networking world was kind of lagging behind the storage and compute section of the world doing it this way. So how it started, so it started before 2009, but it really kind of started kicking off in 2009. Facebook decided that they were going to redesign their data center. They decided they weren't going to pay for proprietary solutions anymore. So they went off and they redesigned their switches, their servers, their storage, rack, power supply, everything within the data center. It took them 2 years, and the end result was a data center 38% more energy efficient and 24% less expensive to run. Now, you'd expect that. That's a new data center. That data center is actually still running, up and running in Primeville, Oregon. But you'd expect that. But the surprising thing that came out of it was they open sourced all the designs along with Intel and Rackspace. And they started an organization called the OCP, so the Open Compute Project. You'll see the logo there. So the OCP deals with everything, as I said, from switches, software, anything that's in a data center, racks, servers, power supplies, liquid cooling is kind of the big thing at the minute. And they also have a marketplace. So I'll explain this a little bit. I'm going to use a 10 gig switch as an example. So what would happen is Facebook would say, I'm looking for a 10 gig switch with 48 SFP plus ports and say 8 QSFP 2800 gig ports as uplinks. So they would give that what they're looking for, that design specification into the OCP. Then guys like UfiSpace might say, okay, we're going to build this and this is the way we're going to build it. And then they'd go off and they'd build a device. Now, hopefully they're going to get a big order from Facebook to start off with, but all their design material for building that switch goes back into the OCP. So if you go into the marketplace, you can click on any of the switches or routers in there, and it will actually give you the full design specification. So if you wanted to, if you had the time and patience and money, you can actually build yourself a switch as well. It's not quite that easy, but obviously that is going to reduce R&D costs for other hardware manufacturers. They don't have to go through the full R&D loop to build that 10 gig switch. There's also, so that's 2011 was OCP, and that was a big success in the hyperscale data center market. So obviously Facebook moved that way. They have their own operating system called FBOSS on bare metal switches. Microsoft did the exact same. They had their own operating system, Sonic, and basically all the hyperscalers did it. So then by 2016, the telecoms industry said, I would like a little bit of that. So they started another organization called the Telecom Infra Project. So TIP for short, basically it's the same thing. So Telefonica, Deutsche Telekom, AT&T will give in design specifications, and companies like UfiSpace will design and build devices for them, and then circulate that information of how to build back into the community. So again, lowering the price and standardizing on the hardware. So there's, I think their marketplace is called the Exchange, but good to have a look at both of them. They've got good hardware, and you can see into that design specification as well, which is quite interesting. Tara, if you want to skip on. Okay, so the benefits of open networking. So better availability. So I was kind of explaining there that there are multiple hardware vendors because of the OCP and because of the Telecom Infra Project, but that it does improve. So actually I'll tell a story to explain it, that during COVID, I think everyone struggled with availability and really long lead times, 12 months, 18 months. We had a specific one because of a power supply, a chip in one power supply, and we were able to move to UfiSpace because Ocnos from IPI goes onto both boxes, and we were able to lower the lead time by I think it was by a year or something like that. So availability is one of the benefits, lower total cost. So this is an interesting one because obviously people look at open networking, and when they're coming to it, they say, we're looking for a cheaper product from proprietary solutions, but it's not always the best reason to move. It has to be on the technology as well. So what we do see though is there's huge CapEx savings. So obviously compared to the proprietary solutions, we have software on the hardware and optics, and that's an awful lot cheaper than the proprietary solutions, but it's all CapEx loaded. So that's all at the front. So you get your box, say it's a 100 gig switch with your software and your optics, and you buy your support contract from IP Infusion for 1 or 3 or 5 years, and that's your total spend. So there's nothing coming down the road in year 2, 3 or 4. So operations for OpEx, it's way cheaper. There's basically no OpEx on the hardware itself. For flexibility and control. So for flexibility, I suppose you could say, so we'll look at scalability and how easy it is to scale open networking data centers. So what we tell our customers, we're going to say, for example, a customer has 2 spine switches and 8 leaf switches. What we'll say to them is, put a spine switch, 100 gig spine switch on your shelf, and put a 25 gig leaf switch on your shelf. It doesn't need an operating system. So because the cost of the hardware is less, you don't need next business day replacements. You don't need anything like that. Basically, you put this in 20 minutes. If you have a broken switch, you can put the software onto the box, put licensing onto the box, and get it into your network. And scalability wise, if you're oversubscribed, you add a spine switch. If you need more port density, you add a leaf switch. It's as simple as that. So no messing around with next business day replacements, which never really come next business day. And then protect against obsolescence. But there's another part to open networking that it was in the original slide there about where it came from and the reason why. But splitting hardware from software was a really important part. So it was the idea at the start was to split the control and data planes. But splitting the hardware and the software, I think, is hugely important because it allows Kai's team at UfiSpace to work on hardware, which is what they're good at. And then it allows Prasanna and his team in IPI to work on software. So them not being linked together means the software, because we can do software bug fixes in a day, a week. Obviously, hardware development cycles are much longer than that. So let the hardware guys do what they do really well. Let the software guys do what they do really well, and then marry the two of them together, which is what happens in open networking. Yeah, if you want to go on there. And what do EPS do? So Kira covered it a little bit with all the dots on the map. But again, it kind of comes back to open networking and having a disaggregation between hardware and software. So what we noticed a long time ago was it's great, the idea is brilliant, but customers do not want to deal with multiple vendors. So they'll say, right, I decide I want a 10 gig UfiSpace switch. Now what software goes onto it? Okay, now what optics are interoperable with that software? It can be a bit of a minefield for customers. So we take that hassle out of open networking. So basically you're getting all the benefits of open networking without the hassle. And there's a product there down the bottom, IPN Fusion Fast. So what we do is we put IPN Fusion's Oknos onto the UfiSpace hardware and ship it to customers. And there's one number or there's one support portal to go through for hardware and software. So again, taking some of the hassle out of open networking, not having to deal with multiple vendors all the time. You want to go on there? And then that's just some of our global deployments. So you'll see, so as Kira said, we split the map up into three. So we have the Americas and we have a distribution hub there. We have EMEA and Dublin, we have our distribution hub. And then Suzhou and China for the Asian market, we have a distribution hub. And you can see there for Europe, we have Vodafone for Ireland, Netomia, who are a big up and coming ISP in the UK, Digi in Romania. There's obviously an awful lot more. I think this would look like a well-used dartboard if we actually put up all the names. Even in Africa there, we have VTS, but we've worked with basically all the ISPs down there. So MTN, Africell in different countries, Afrabone in Mali, and the same in the US. As I said, it would look like a dartboard if we put all the names, but that's just a flavor of some of the global deployments we've done with Oknos and UfiSpace. So I think that's me. So I will hand you over to the gentleman from UfiSpace, that is Kai Lee in sunny California.
Great, thank you, Barry, and good morning or good afternoon. This is Kai Lee from UfiSpace. I'm located in San Jose, California, here in Silicon Valley. So I'd like to spend the next few minutes to talk about the efficiency and all the good benefit of the open disaggregated hardware, how that fit into the data center. Next slide, please. Okay, just a little bit, maybe 30 seconds or a minute to talk about our background. We've been around in the industry for more than a decade, and then we focus on hardware, disaggregated hardware architecture, leveraging all the merchant silicon that is available in the market. As compared to the OEM, the merchant silicon give us the economy of scale because they are building the chip not for a few companies, but for the entire industry. With a lot of these open standards, then we can pass the economy of scale benefit back to the end customer on both the OpEx and the CapEx. We'll talk a little bit about it. Our company is really engineering focused, with the majority of the company make up with R&D engineering and then all the support team. On top, we are showing our footprint around the world with the headquarters in Taiwan. And then we have a support team both in Europe, North America, and also coming up in Japan. And our manufacturing site is in both China and also in Vietnam, partnering with one of the largest contract manufacturing vendor in the world. Next slide, please. Okay, great. Thank you. So kind of give a quick comparison of, the benefit of the merchant silicon versus the traditional network switching design. As mentioned earlier during this intro today, when you build a data center from an efficiency perspective, data center always come with three components. Doesn't matter you are in a banking or high tech or whatever industry, you always need the following three things in a data center. There's compute, storage, and network. We play in the network sandbox. We partner with other folks on the compute and also in the storage. Those are the three key components that to operate in the data center. So allow me to focus on the network piece, but the concept apply to the other component. In the traditional solution with the traditional network design from an OEM closed vendor, closed meaning they tightly couple the hardware and the software. They may using their own application-specific IC. It could be good, it could be bad, and we'll talk about that in a second. But the blue line in the middle shows the different pieces that we had to go through with the branding markup and all these other support challenge versus the open disaggregator. Why Facebook kick off OCP and TIP and is gaining so much momentum in the last decade is not only because of the openness, but also having some of the direct access and direct benefit to the end customer, and basically making the whole model a lot simpler. As mentioned before, no more next business day ship, because the box are built with a lot of the open component. It might be cheaper not to have a service contract if anything not needs to be fixed. Maybe it's easier just to replace those than buying a very expensive service contract. So that's the concept. On the bottom, I like to support this with a couple of facts. These are real numbers that we are collecting from the industry. So from the left to the right on the bottom, we are showcasing a couple numbers. So if we, leveraging the OCP spec, which they are driving all the open specification. So basically from year 2020 until now, so the open disaggregator model on the switching side, the adaptation has gone from 6% to 17%. So that's a pretty significant adaptation coming up from that whitebox disaggregator perspective. In the middle, UV Space is actually working with a very major carrier in North America, and some of the audience, if you are in the US, you may be using their cellular services. And then right now, with the disaggregator architecture, using some of our solution and then some open disaggregator software, more than half of their traffic is running on the disaggregated architecture. And these are real production numbers that we're bringing to the table to share with the audience. Then on the right-hand side, we also are looking into some of the data point on the optic, using the ION, that's the innovative optic and wireless network organization. So the operation costs with the open standard are actually driven down by almost half, and then with the power consumption saving. For those of you in hardware or you are familiar with hardware, when you look at the network switches, the open I/O with the optics and all these things is not only consuming a lot of power, but also we have to deal with the heat dissipation. I talk about this in a second, but so the power consumption saving, not only from the merchant silicon, but also from the I/O can be very significant, because the faster the speed when you go from 100 gig to a 400 gig or to even the upcoming 800 gig, we spend a lot of time in hardware design with the I/O power consumption saving, as well as the how to manage better with the heat dissipation. So that piece is quite a challenge to manage. But now with the open standard, there's a lot of room for us to make the whole thing better for the end user. Next slide, please. Okay, just a little bit with more data. So we use a lot of off-the-shelf merchant silicon from the industry, and allow me just to pick the Broadcom Trident family as an example. So what we are showcasing here on top is going from a Trident 3, which is a 12 nanometer technology, to a Trident 4, which goes down to 7 nanometer, and now the latest with the Trident 5 with a 5 nanometer. And the way Broadcom measure this power consumption is by per 400 gig worth of traffic. So from a Trident 3 at 12 nanometer technology to a Trident 4 7 nanometer, every 400 gig of traffic sent being processed by the chip, we now save more than half of the power consumption on the chip. And going from a 7 nanometer to a 5 nanometer with the latest, we save another 25% per 400 gig amount of traffic being processed on the chip. So the smaller the nanometer, two things come to the table. When we talk about, you know, the 12, the 7, the 5 nanometer, what they are talking about is the gap on the dice where you can shorten the gap on the PNP or the NPN transistor. What that means to the end user in plain English is you can fit, or we can fit more gates, more intelligent into the same surface area of the wafer, resulting into higher power and then more power consumption, but taking higher power for processing, but taking less power for the consumption to drive the chip. So those are the two key things. Let me summarize this again. The smaller the nanometer, the more gates we can fit into a wafer, resulting into more computing power in the chip. And then we also consume less power to drive the chip per X number of traffic that go through the chip. So those are the benefits. And then on the bottom, we are showcasing that by optimizing the design I just explained, we can improve the power efficiency on the side. And then on the right-hand side, UV Space actually adapts something called the micro-venting technology. So on the airflow, we put a lot of study on the mechanical design by using a more rigid material on the chassis. We can make the venting holes a little bit smaller hole with the same amount of airflow actually increase the air pressure. That's just a standard physics 101. And because of that, we can actually improve the cooling efficiency by about 25%. With this thing called the micro-venting technology. We are actually building some of our latest 7 nanometer and 5 nanometer device on the box using the micro-venting, so we can continue to improve the efficiency. Now, one more thing on the data center for those of you in this business, 3 things you always care when you design a data center, and that is power, space, and cooling. So we are addressing both the power and the cooling. And then with the disaggregated model, because the box is actually broken down functionally, you know, into like a 2 RU and cluster them together. So spacing is also another element that we are also trying to make it to be more efficient. So that's power, cooling, and space. Next slide, please. Okay, speaking of cooling, another proof of concept we are doing right now in our Taiwan Development Center is the liquid cooling. Long story short, if I can call your attention to the left lower corner, I'm just throwing in some of the latest chip as an example. A Trident Tomahawk 5 from Broadcom. The power consumption on the chip right now is 790 watt. A Tomahawk 6, you know, is 1218 watt. If you look at NVIDIA, one of the AI chip is in the thousands, is 1200 watt, you know, with this kind of power consumption. The higher the power consumption, the more heat it will generate. Traditionally, we use heat sink. We make the heat sink bigger so that the surface area is bigger, so we can basically doing the conduction, the convection with the radiation, so the heat can go away, you know, inside the box. Now, when these chips are consuming so much power with all these high processing requirement, especially the AI chip, so we are bringing in the experiment of the liquid cooling. Long story short, liquid cooling is actually based on a substance at a high level called a PG25. It's kind of similar to the concept of the cooling that you use in your radiator in your automobile, but it's far more complicated because it's the dielectric of the characteristic of all the electronic component we are cooling inside the box. So this substance has to be certified with the dielectric behavior and be able to work with all the active and passive component inside the hardware design. So this picture, what we are showing is what we call the cold plate. Cold plate is nothing more than the same concept as the heat sink by air. Cold plate is the similar concept, but by liquid cooling using this liquid substance I talk about called the PG25. On the right-hand side, we introduce this thing called the CDU, and basically it's a cooling distribution unit. When you build a data center for efficiency, the CDU can support a whole rack, or they can support a number of racks. In a data center deployment. It's extremely scalable, depends on your requirement and your size. So in some of the liquid cooling deployment, you may see a CDU on the bottom of the rack cooling the entire rack, or you can see a bigger CDU on one side of the data center and cooling the entire racks of equipment, horizontally. So those are some of the deployment model. I just want to kind of bring to the audience to improve the efficiency and the cooling and all these. So it's really evolving from the traditional heat sink, the airflow, the front to back or the top to bottom or the bottom to the top type of cooling, and now bringing it into a different way of doing the cooling technology, because some of these new chip, especially the AI chip, are consuming a lot of power. Next slide, please. Next slide, please. Okay, great. So kind of in closing, as I mentioned before, when you build a data center, doesn't matter you're running a banking business or a finance or, manufacturing, you always need three things: network, compute, and storage. In fact, if you take a look at the public cloud, if you go to AWS or Azure or Google GCP, I want to provision a virtual environment. You always have a virtual virtual compute. You always have the virtual network, including maybe firewall and all these other virtual functions. And then you also have the virtual storage. So that is kind of like a network design 101. So what we are showing here from an efficiency perspective is to build a data center on the traditional spine leaf, introducing also another layer at the top of the rack to connect all the compute. If you are using fiber channel over Ethernet, then we can connect directly into the storage. If you are using the traditional fiber channel, the 16 gig, 32 gig, then we introduce the SAN switch, the storage area network switch to home this into this whole architecture. From an efficiency point of view, this architecture called the CLOS, CLOS, is basically the cross connect between the spine and leaf. Is extremely scalable. We can scale this horizontally from an efficiency perspective. It's a pay-as-you-go model. We have all your compute farm, all your storage farm to be built within the same part for your department or your organizational need. As your company expand, we scale this horizontally and just keep adding this pizza box with some of these high profile chip to continue to drive the traffic pattern. So you pay from an efficiency, you pay what you need, and then you expand as you need to. You preserve all your investment with all the equipment and all these other things we talk about. Next one, please. This is my final one. I just kind of want to show the audience we came a long way. From the 1 gig on the left all the way to the 400 gig and 800 gig solution. I'd like to call out two things on this mapping here. If I can call your attention to the right-hand side, the world is at 400 gig, migrating to the 800 gig merchant silicon. So the chip are coming out more powerful. We can fit more higher density compute storage type of end user application related resources into the data center. In the meantime, the chip is getting more dense, so the device is not getting bigger physically. They actually either stay the same or smaller. But because of the expansion of the size of the network, we continue to focus on the cooling, the space, and also the power consumption. that kind of summarize what I talked about in the last few slides, how we continue to work on the cooling part, the power consumption, and all these other things to make the end customers' data center to be a lot more efficient without compromising the computing power. And then with this high speed, the last thing I like to leave with the audience, building the 400 gig, 800 gig, and all these other things is because the compute resources are coming in with 100 gig interfaces. They are no longer, coming in like the old days, a 10 gig port. They are coming in server farm with a 100 gig port. So we have to drive the backbone to 400 gig, maybe even 800 gig, so that we can continue to provide the flexibility and the scalability of the whole data center efficiency. So that's kind of summarize the whole concept and the architecture. So I turn over to our partner from IP Infusion to talk about the software side.
Yep. Thank you, Kay.
Thank you.
Hi. Hi, everyone. So I'm Prasanna Kumar S, Technical Marketing Engineer working in IP Infusion. So I'm very glad to hear what Barry has summarized and Kay has summarized. So Barry has summarized about disaggregation and the benefits of disaggregation, which is bringing into the networking world. And Kay has beautifully explained about how the hardware innovations are happening and how they are bringing the latest innovations to the customers. Thank you. So now I'm going to talk about the motivation behind, why we are here to, why the technology here, what technology is offering in terms of getting the operational efficiency and the scalability. So I'll talk from a software perspective, what are the software advantages happened, so which will give you the operational efficiency and the scalability. The first thing, like, what is a motivation? Motivation is that we have seen that we have come a long way in the networking, and virtual computing is becoming a reality. We cannot get away with that. We have to embrace it. So there are many virtual computing things. So VMware vMotion is there, and then Oracle Rack is there, and the Windows clustering is there. So there are many virtual computing systems are there. So they have been providing the vMotion to meet the business needs. Okay, and to support the vMotion or moving of the VM from one place to another place, the L2 becoming a necessity in the data center. And when L2 is there and the network is growing, it becomes tough to handle the L2 network because STP problems, and because of that, data storm can happen. And when the problem happens, tracking a VLAN, it becomes a tough. And when the network is growing, so to track a VLAN, we have to color it in a chart. So the chart becomes bigger and bigger when the topology becomes bigger, and it becomes tough to track a VLAN, which path it is going. Okay. And also whenever a problem comes, it becomes tough and time consuming. It becomes an headache thing to solve it. Okay. And because of the microservices, right? So because of the coming into the containers, hypervisors, and more multi-tenancy, so a lot of microservices are coming into the picture. So they are bringing in the need of increasing the number of VPNs. So that says that the 4K VLANs are not enough. So we need a bigger VPN services. So that is where the need is. Okay. So how do we handle all these things? We have to take a control of it. So how do we do it? We have to move to the control plane from the data plane of the MAC learning. I'll explain more about it. And then we have to embrace the L3 because it provides the shortest path and ECMP, and it also provides a very good recovery mechanisms, right? And then we can talk about how we can focus on how do we can provide more better services to the customers, and how we can expand the present network into a greater scalable things. So those things we have to take control over it. So let's move on to the next slide and try to understand how EVPN-VxLAN offers these things, and along with the class fabric. Let's see the EVPN as a technology. It's a beautiful technology. It supports multiple tunneling protocol, tunneling methods. Okay, and for the data center, we have chosen VxLAN because it works over the IP and it is easy. Okay, and what EVPN brings is it brings a large multi-tenancy because it's a it's a very big number. Okay. And it also helps in auto discovery of the VPN endpoints. That means that wherever the VPN is connected, so that will be visible just by a show command, seeing that, in what and all VTEPs it has been connected. So we don't need to really go behind the graph and trace the color, where and all it is going. So that's an, very good advantage. And also the control plane learning of the Mac. So since we are bringing the overlay as a VxLAN, so what we are doing is we are learning the Mac in the control plane. So that helps in, so only the endpoints or the VPN, wherever it is configured, only those leaf devices would need to know the MAC addresses. So that means that the MAC table of the hardware is used very, very efficiently. And in between spines, they're not even aware of what are the MAC traffic is going through, because it is going in a tunnel. So that's the advantage it is bringing in. And also, it provides the services of L2 VPN, L3 VPN, IRB, multicast, and many more in one control plane. It's a EVPN control plane. Now, if you see the earlier world, for L2 VPN, we have to use a different protocol. L3 VPN, we have to use a different protocol. And clubbing together, there was no solution. And now EVPN is coming and bringing the IRB. So that gives a lot of advantages of ending the L2 at a closer to the top of the rack, right? And it also brings MH redundancy, which has been standardized. So till now, whatever we have seen, MCLAG are all proprietary. So now EVPN comes and it makes multi-homing as a standard, and not just limited to the 2-node. Tomorrow it can expand to the more number of nodes for the redundancy handling purposes towards the host. And towards the network, because it is using the L3, it provides the ECMP load balancing. So these two things were not there in the VLAN context. Okay, so that EVPN is bringing. And it is also bringing the E-line service, E-LAN service, and E-tree services. So E-tree service is something new to the VLAN world. So where the subscriber will connect to the service provider and they will be able to talk to each other, but subscribers will not be able to talk to another subscriber. So these kind of beautiful solutions are coming up with the EVPN. And to complement that, the class fabric is a network architecture which has been evolved to solve the problem of how do we efficiently connect the devices to have a better predictable communication. Okay, so the class fabric, the advantages with this is, and including the EVPN and including the unnumbered interfaces, it is very, very less config on each of the node. We just need one loopback IP configured on the device as an IP device, and remaining interfaces are connected with the unnumbered. You just enable the eBGP and all nodes will be connected and ready to communicate with the VPN communication. That's why it becomes even easy to automate. And the class fabric is easy to expand because we can keep adding leaf and spine as per the demand and the network growth, and it doesn't affect the existing services. And the moment we add them and configure the VPN, it starts pulling the load. That's the beauty of it. And it is predictable because if we see the class fabric, so the spine sits in the top layer and leaf sits in the lower layer. So every leaf is reachable by other leaf just one hop away. Okay, the network is now very much predictable, whatever we expand and whatever number we add. So that is the beauty of this class fabric. And it also provides full ECMP, which will help in load balancing and efficiently using the network and all the links and all the nodes. Okay, and it also tells us that we can use single control plane, which is eBGP, for both underlay and overlay. So this actually reduces the OpEx cost because one need not know multiple protocols to handle this. So just knowing one eBGP, which is more well proven protocol with lot of controls, right? So which can be sufficient for both underlay and overlay. So these two combining together, they are bringing greater benefit to achieve the operational efficiency and also the scalability. Let's move on to see that, how Ocnos is helping in this and what Ocnos is adding to it. Okay, so before to that, I'd like to present what IP Infusion has been doing all these years to bring the software innovations, right? So the IP Infusion is there from 25 years. It has been found actually because earlier Zebra OS was there. The same founders came, no, we have to address the enterprise needs. That's when they have founded this company. The same Zebra OS, now it became like a Jeb OS and then Ognos, right? The same innovators have made this company. And then we have been in this field for more than 25 years, addressing the customer needs. And we have been providing our software to multiple OEMs. So they have been giving back, they have been coming back and asking us to improve and then fix the issues. So in that way, we have been improving throughout this journey, right? And now we have 400 plus employees and multiple R&D centers, and we have 600 more than 600 customers and more than 10,000 deployments. We have got good badges also to prove, and the same software flavor would be available on all like service providers, data centers, and OEMs. So that's the beauty of it. So once they learn, and it is the industry standard CLIs, it is easy to learn. So once they learn, so it is easy to handle service provider integration with the data center and as well as other use cases. So let's move on and see that. Okay, so we have been bringing the innovation I was talking about. In this slide, I would like to emphasize on what Ognos is additionally bringing into the DC apart from what EVPN-VxLAN we have discussed. Okay, so what Ognos provides is the true independence from the VLAN. So in the way that if we compare with the other providers, so they will just provide VLAN to VNI mapping, whereas Ognos is able to provide a particular port plus VLAN we can assign to a VNI, or we can assign all VLANs or all traffic on a port, like a port mapping. And also we can assign a SVLAN, CVLAN combination on a particular port to a VNI, right? And also we can assign a VLAN range. It is based upon like, what is your customer asking? Let's try to address all the things. And even we can map the VLAN also to a VNI. So all the facilities are available. And a different VLANs also can talk to each other in a given VPN context. So this definitely helps and simplifies the realistic problems which come. Let's say when a customer comes, hey, I have this VLAN, but then the operator need to see that, hey, I don't have that VLAN free on the bridge. So then you need to find another switch. So that's not the case over here. So it is easily doable and it is helpful. And the other differentiating factor is that, so since we have a port mapping, so we also have a ARP cache and ND cache facility available within the L2 VPN context. Okay. And just not the ARP cache. So because ARP cache, when it has learned the IP address initially, the later L2 traffic can continue and one can remove the IP address. So then ARP becomes a stable. So then the switch is having intelligence to revalidate itself, so that it sends a request and then it tries few times and then it tries to remove the entry if it is invalid. Okay. And also there could be some cases that they want to really completely suppress the flooding into the network. So in that case, they can use a storm control, right? So, but ARP and ND falls into that bump traffic rules, okay? And we are also providing the ARP cache and the ND cache. And whenever a cache miss happens, to discover a host, we have to send the request, and that would be a bump request. So in some cases, people doesn't want to have a bump at all. Let the switches learn the, whoever host comes with a GAR. So in that case, we can completely stop that ARP and ND, even though cache miss happens. Okay. And also we have a provision for statically sticking the MAC address or a MAC and IP combination or a MAC and IPv6 combination. This helps to, in terms of operator, this helps them to fix the IP so that, it doesn't really move across by any mistake. Okay. And with respect to the services, we are providing the ELAN, and E3 is also coming into the picture, which is a differentiator when compared to the other operators. Okay. And moving fast, So EVPN standard multi-homing, what it offers is that there is no intermediate link, so that we need to think of provisioning and we have to plan the bandwidth for that. Okay, provisioning a bandwidth is a greater challenge in an MC-lag, so that is not required with the standard multi-homing. And also in the case of IRP, so we are bringing, it has to provide the Anycast IP, and along with the Anycast IP, you can choose which IP to be the Anycast. So that helps in determining that which will act as a forwarding IP and which will act as a peering IP. So both can be done. So that's a very good advantage. And when it comes to the IRB, so IRB can be done, it can be used in making an L3 VPN. And in an L3 VPN, we can use IRB or without IRB, or a combination of IRB and a regular SPA and physical interfaces. And it also provides the distributed and centralized IRB cases. And because of that, one can terminate easily closer to the top of the rack switch. And when we provide L3 VPN services, DHCP relay is required. So that's also provided. And another thing, good thing is that the traffic loop, how do we detect and how do we recover, right? Because EVPN helps us to understand where the MAC is moving. So because of that, when we see faster MAC move, so then we will put that in that MAC thinking that, hey, it is looping somewhere. So then we will block it. And it will also try to recover by unblocking it to see that whether the situation has recovered or not. So this automatic way helps in bringing back the traffic with a lesser intervention. Next slide, please. Yeah. So these are all the features we discussed, what additionally we have offered. All right. When it comes to on what and all switches we are supporting the OPNOS is, the switches ranges from the management switches, leaf switches, spine and super spine, and the bandwidth ranging from 128 gig to 51.2 terabytes. So thanks to the hardware vendors, and also the software is coming up with, meeting all these needs. And the key use cases are DC class. And also it helps in the AI payload, taking through the AI payload, because we support DCB and PFC things, and which will help in Rocky V to communicate. And also the out of band management network is there. Okay. So hope this helps. The next slide, please. Yeah. So in a summary, so why IP infusion and what it is providing is, it is providing a network operating system over an open hardware ecosystem, which we discussed as an OCP, right? So, and it is providing the solutions across access, aggregation, and transport and the data center. The software is very much mature, and it has been gone through many cycles and in many devices, in many deployments, and it is providing beautiful, rich set of features. More than 700 features are available. And okay, and also the optics part, when it comes to the optics part in the devices, it provides 400 gig supports, and as well as ZIA Plus, and it is also provides IP Maestro for the point and click, and we have a beautiful 24/7 professional support, which will help you to, deploy this with peace of mind.
Brilliant.
So
Thanks
with
so
that,
much. Oh, sorry.
I would end it. Yeah, thank you.
Thanks a million, Prasanna. Thank you, Kai, and thank you, Barry. That was insightful. I just wanted to jump to a few questions. We're going to make sure everybody's out of here under the hour, because we don't want to keep you too long. So we'll go through these quite quickly. The first one, I think this one is for you, Kai. It's how do you keep competitive against incumbent vendors like Cisco or Juniper?
Sure. Yeah, that's a reasonable concern. So first of all, I'd like to highlight like a couple key points how we do that. With the open disaggregator model, leveraging the merchant silicon, as I mentioned during my presentation, we are not collaborating with one or two large vendor like Cisco or Juniper. We are collaborating with the entire industry, and we are taking advantage of the open foundation like OCP, which is enterprise data center focus, and also the TIP, the telecom infrastructure project, which is carrier focus. So together, collectively, the whole industry are migrating to this. So we are no longer just like collaborating with one or two very large vendor with a good market share. We are collaborating with the entire industry, leveraging off the shelf. And the second data point why this trend is actually moving that direction, because if I'm talking to you like 5 or 6 or 10 years ago, merchant silicon wasn't as powerful as they are today. If you look at some of this merchant silicon off the shelf, they can do a lot more with all the advanced built-in features and all these other things that they couldn't do years ago. So collectively, with the trend of the industry is migrating, taking advantage of the merchant silicon off the shelf, become far more powerful than they were a couple of years ago. So we think this is a very good opportunity, and that's why you see a lot of Fortune 500 customer, tier 1, tier 2 carrier already adapting into this. And again, I really want to emphasize one key data point. We are taking advantage of this open foundation, OCP for data center, HIP for carrier, because all these are driving all the people together to work collectively. So this is something that we feel very confident the trend will be continue that way.
Okay, great. Thank you. This one is about Oknos. So I assume, Prasanna, this is for you. And I actually saw it on your slide there, but someone has asked about AI or machine learning. Are there any features in your software that enables that?
Yes, it's a good question, and it's the current need. So there are AI data payloads are increasing. So we have EFC available, and we have DCB things are available. So that will take care of communicating the information back to the source. So that will help in taking a payload across the class fabric.
Okay, great. This one might be Barry. So someone has asked, do they have to buy Oknos and UfiSpace hardware separately? Or can it be bought together, or basically someone is looking for a single point of contact?
Yeah, I kind of touched on it during my slides. So yeah, you can buy them separately, but it's better to buy them individually. So we kind of call them bundles. So you would get Oknos on the UfiSpace box with 1, 3, or 5 year support from IP Infusion, delivered to your location. And again, you're not paying the subscription model after every second, third, fourth year. So yeah, we found that in the industry from the last decade that they didn't want to be looking, is this a hardware problem? Is this a software problem? So you'll have one kind of technical support center to go after if there's an issue. So yeah, bundle them together. It's the easiest way.
And that's you. It's your neck that they can wring.
Yes. Well, myself and Prasanna, I think, get that end of it. Yeah.
Okay. So there's a question asking about, should I worry about the interoperability when adopting a whitebox solution? So I think maybe Kai, can you give me your perspective, and then Prasanna,
Sure.
I'll ask for your perspective. So that's someone who would be worrying about interoperability with whitebox.
Sure. Okay, sounds good. Yeah, and I think that's a reasonable concern if you already invest quite a bit of the capital equipment from the OEM side of the solution, and now you bring into the whitebox. There are a couple of things that you might think about, and I think that's reasonable. But let me highlight into like 2 or 3 key data points. Number one, from a conductivity perspective, Ethernet is Ethernet. TCP/IP is TCP/IP. So everybody follow the same standard of the Ethernet frame format, the TCP/IP, the packet format, and all these other things. So all these things are interoperable. In fact, we have large carrier customer, we have large data center customer already having a hybrid environment with whitebox, disaggregator box running with the traditional OEM solution. They are working together. That's from a connectivity perspective. From a software perspective, leveraging, open software like API and all these other partners, a lot of these API calls are pretty standard if you follow kind of the industry. So, at a protocol level, when you have 2 IP devices talking with each other, let's say over Metro Ethernet, the format, the standard are exactly the same. So from an operability perspective, these things work together. And not to mention hardware company like UfiSpace, we actually do a lot of interoperability type of testing in our Taiwan development lab. all the way down to the optic level. You know, when we bring in a new 100K, 400K optic, we actually interrupt our device with another OEM vendor device, that kind of testing to ensure that we don't see any discrepancy, and also to ensure, you know, everybody follow the same IETF standard to ensure the two parties are working together. But more importantly, I think the most powerful data, I leave this one last data point, these things are already happening. We have large enterprise customer, large carrier customer are running in a mixed environment, because this is not a forklift upgrade. You have to kind of like shrink and grow. And then it's already proven in this production network, the two sides of the system actually coexist and they work together well.
Okay, perfect. Prasanna, can I get a quick answer from you as well on that, if you don't mind?
So it's all about open standards, open. So from the top, we have open config, open compute, and open optics. So everywhere it is all standards driven, and whenever it receives a packet and it sends out a packet, all are standard based. So that we have been doing a lot of interrupt testing, and there are many deployments where interrupt have been proven, and we have gone to even EANTC sometimes, you know, to do all the interrupt testing. So the interrupt is the basic thing, you know, which we have to provide to be in the network, and we have been doing it from past 25 years.
Okay, so the answer there is interoperability isn't an issue, but if you have any concerns, you can talk to us about those, and we'll allay your fears. I guess that just leaves it for me to say, you can see on screen there's a QR code, and we have some, you know, try and buy kits if you're interested in exploring our bundled solution with UfiSpace and IP Infusion for your data center. You'll get Barry on the phone, or you'll get Prasanna or Kai. You've met them all now virtually, so we'd be delighted to set one of those up. And I'd like to say thank you to everybody for joining today. There's 4 more questions that we just didn't have time for, but we're going to answer those people individually by email after. And thank you for your interest and your questions, and have a nice day.
Thank you. Bye-bye.
Thanks,
Thank you.
Kira. Thanks, Kai.
Thank you.
Prasanna.
Bye-bye.
Bye-bye.